Okay, so Bacho, we are going to start the next thing or the next chemical reaction of amine. And over here, I am just going to start with a coupling reaction. I'm going to start this coupling reaction, right? What is this coupling reaction means? Bacho, coupling reaction is one of the reaction of, you can say that amines in which you are going to form diazonium salt, right? We know that we talk about in the last class that we have diazonium salt, which can be produced from phenylamine, right? So this is one of the diazonium salt, right? This is diazonium salt. We know that this is diazonium salt. We talked about this in the last class, right? This diazonium salt can be converted into dye, right? It can be converted into a azodye, right? You can see this. How can we convert this? This is the next thing, but you need to remember this, that we can convert this azodye into azodye, right? This is the structure of azodye. This is the structure of azodye, and the structure of azodye is actually a colored, it is a colored dye. This is a colored dye. You can use this in a different purposes, for the different purposes, right? This is one of the dye we use in textile and other things, right? So this is the substance you can form from diazonium salt. In the last class we talked about diazonium salt, so I just want to show you that why diazonium salt is very much important. We know that diazonium salt can be produced from phenylamine. This is the phenylamine, and we converted this into diazonium salt in the last class. And now I am telling you that कि ये diazonium salt बच्चों ये azure dye में convert हो सकता है, यानी कि colored dye में convert हो सकता है, and then you can use this in industries for the coloring purpose. All right. So you need to keep remember this, that how can we do this? You need to keep remember, first of all, what you need to do for this process. You need to have at least one phenol, right, for this, and you need to convert phenol into phenoxide like this. You need to convert phenol into phenoxide, and you can easily convert this with the presence of NaOH aqueous. You can easily do this in the presence of NaOH aqueous. Once you did this, so it's the second part is what you have, what diazonium salt, which is like this, right? This is diazonium salt. This phenoxide and the diazonium salt are going to react together. When they react together, they will form what? Azodye, like this. This is the azodye. The one of the bond of nitrogen is going to be break over here, and then it will be connected with the phenoxide benzene ring, and over here this negative O is going to be balanced by hydrogen. So in this way you can form what? Azodye. There are three steps for this. This is one of the colored dye which you can produce from diazonium salt, and we know that diazonium salt can be produced from phenylamine. All right, bacho, that we already talked about in the last class. If you don't remember this, so I can show you over here. You can see this, that we were talking about this in the last class, that you can convert phenylamine into diazonium salt. This is diazonium salt. You can see this over here. You can do this in the presence of dilute nitrous acid and at 5°C temperature, right? Once you make this, you can convert this into azodye, right? This is one of the industrial use of this compound, right? Every one of you?
Yes, sir.
This is very simple, and you need to learn this, right? So let's move on. If you talk about the next thing that we need to understand in this is actually what? Just look at over here. For suppose right now You can see this. I am talking about this again. So for suppose you have this compound again, diazonium salt. This is diazonium salt, right? This is diazonium salt, right? You can see this. For suppose if I am going to add this is the other thing. If I am going to add methyl phenol in the presence of excess, or you can say that in the presence of NaOH aqueous, if I'm doing this in the presence of NaOH aqueous, bacho, so you need to keep remember this, that this is what? This is 2,4 directing group. If you talk about this, so it is actually 2,4 directing group. सो आपके पास जो भी चीज अटैच होगी या तो वो दूसरे कार्बन पर हो सकती है या तो वो चौथे कार्बन पर अटैच हो सकती है, ठीक है ना? या तो वो दूसरे कार्बन पे हो सकती है तो या तो वो चौथे कार्बन पे हो सकती है। आप देखें तो यहाँ पर आपके पास जब कंपाउंड बनेगा तो वो कैसा बनेगा? जस्ट लुक एट ओवर हियर। ये आपके पास मौजूद है OH, राइट, और यहाँ CH3 मौजूद है। तो आपके पास जो डबल बॉन्ड N होगा वो कहाँ अटैच हो सकता है? फोर्थ पे अटैच हो सकता है, ठीक है ना? बिकॉज इट इज 2,4 डायरेक्टिंग ग्रुप। तो या तो ये 4 पे अटैच हो सकता है या तो वो सेकंड पे अटैच हो सकता है। सेकंड पे ऑलरेडी मिथाइल अटैच है, सो आई एम जस्ट अटैचिंग दिस ऑन द फोर्थ वन। यू कैन सी दिस कि ये बन गया आपके पास एक और एज़ोडाई, ठीक है ना? यू नीड टू कीप रिमेंबर दिस, right? For suppose I have this example, कि आपके पास है क्या? You have diazonium salt. This is diazonium salt, right? And you're reacting it with another compound in the presence of aqueous NaOH, and the compound is like this. This is phenol, this is CH3, this is CH2, CH3. We know that it is 2,4 directing group, so definitely the nitrogen is going to attach on the fourth carbon. So you can see this. This is the first carbon, second, third, and fourth. So nitrogen should be attached on the fourth position. So it will be like this, that this is remains same, CH3 on its place, CH2, CH3 on its place, OH on its place, right? And the nitrogen is going to attach on the fourth position because it is 2,4 directing group, right बच्चों?
सर
जी बेटे।
सर ये जो हमने CH2 CH3 वाले एग्जांपल लिए उसमें CH3OH वाले एग्जांपल लिए उसमें सेकंड कार्बन पे तो CH3 एक तरफ लगा हुआ है, लेकिन अगर हम दूसरी साइड से काउंटिंग शुरू करें तो वहाँ पे सेकंड कार्बन पे लग सकता है।
बिल्कुल लग सकता है, just 2,4 directing group, so you can easily put that.
ओके सर।
ठीक है, and then for suppose I have one more example over here like this, example number 4. If you talk about example number 4 bacho, just look at over here what I'm trying to draw over here. For suppose you have this structure. These all are structures from past papers, right? So you can see this, these all examples are from past papers. This is one of the structure in which you have phenol over here, right? This is phenol for suppose now. So you can see this, if I am going to react this with the diazonium salt, so what should be the structure? I should have from this phenol, इस फिनोल से मेरे पास डायजोनियम का क्या सॉल्ट कहाँ अटैच हो सकता है? वी नो दैट कि हमें अटैच तो यही वाला पार्ट करना है ना। ये फॉर सपोज मैंने आपको नहीं दिया, मुझे यही वाला अटैच करना है, तो कहाँ अटैच हो सकता है? यू कैन अटैच इट ऑन द सेकंड कार्बन और यू कैन अटैच इट ऑन द फोर्थ कार्बन, एंड फ्रॉम यू कैन अटैच एनीवेयर, राइट? सो this is the first carbon, this is the second, third, and fourth, and this is the second. So I think the second one is more feasible right now क्योंकि वो बिल्कुल अलग है, तो मैं वहां ड्रॉ कर देता हूँ, ठीक है? तो ये स्ट्रक्चर ऐसे ही रहेगा आपके पास, इस फिनोल को कुछ भी नहीं होने वाला, ठीक है ना? ये एज इट इज रहेगा, और जो डाइजोनियम सॉल्ट है वो आपके पास यहाँ अटैच हो जाएगा सेकंड कार्बन पर, सेकंड पोजीशन पर, राइट बच्चों? और यू कैन इवन फाइंड आउट द फिनोल, अगर वो आपसे पूछे बताएं कौन सा फिनोल यूज्ड हुआ, तो आपने करना क्या होगा? सिंपल, आपने यहाँ से बॉन्ड ब्रेक करना होगा और आप बता देंगे कि भाई हमने यहाँ पर ये वाला फिनोल यूज किया, ये वाला कंपाउंड हमने अटैच किया। वो कुछ भी पूछ सकता है एग्जाम में आपसे, वो भी आपसे ये पूछ सकता है, वो आपको ये डायग्राम दे दे और वो डायग्राम देने के बाद आपसे ये पूछ ले कि बताएं इसमें कौन सा वाला फिनोल आपने यूज किया था। डायजोनियम सॉल्ट तो आपने ये यूज किया और फिनोल कौन सा ऐड किया था, तो वो आप उसको कट करके ऐसे बता सकते हैं कि ये वाला जो पार्ट है हमने ये फिनोल के तौर पे यूज किया था, ठीक है ना। या हो सकता है वो आपको ये पूरा कंपाउंड दे दे या आपको सिर्फ फिनोल दे दे और वो डायजोनियम सॉल्ट ना दे और कहे बताएं फिनोल बना के दिखाएं, या हो सकता है वो दोनों चीजें दे दे और फिर आपसे स्ट्रक्चर पूछ ले। तो examiner can ask question in any way, you need to be prepared for this, right? So that is why I just show you the 4 different examples for this dyes, right? So these dyes are differently used in different industries for different color or for different purposes as well. So ये हम इस तरह बना सकते हैं, अलग अलग डाई अलग अलग कलर प्रोड्यूस करेगी और इनके अलग अलग पर्पसेस होंगे, ठीक है बच्चों।
यस सर। सर ये जो हमने एग्जांपल नंबर 4 में फिनोल वाला जो स्ट्रक्चर बनाया है उसमें दूसरे रिंग पे कुछ भी नहीं होगा?
ये तो स्ट्रक्चर पे बात है ना, आपकी मर्जी है, आप अगर वो दूसरे स्ट्रक्चर वाला देता तो आप उस तरह बना लेते। ये हमारे पास एक एग्जाम का क्वेश्चन है तो जिस तरह बना हुआ है तो मैंने आपको उस तरह बना दिया, किसी भी तरह बनकर आ सकता है। देखिए मैंने 4 डिफरेंट फिनोल्स यहाँ लिए हैं, एक CH3 वाला है, एक CH3 और CH2CH3 वाला है, एक सादा वाला है और एक डबल फिनोल वाला है। तो वो कुछ भी लगाकर आपको दे सकता है, बट आपने याद रखना है कि जहां OH लगा हुआ होगा उसके बराबर वाले कार्बन पे या उसके बाद जो 4th कार्बन है उसके बाद वाला, वहां पर आप अटैच कर सकते हो डायजोनियम सॉल्ट और वहां डबल बॉन्ड बनाना होगा, ट्रिपल बॉन्ड तोड़ना होगा आपने, बस आपने ये याद रखना है, ठीक है।
यस सर।
Yes, every one of you, is that clear? Ahad, Hamza, Rabel, is that clear, bete?
जी
यस सर।
Okay, so let's move on now. We have some more things to remember, बच्चों। If you remember this thing, so can you please tell me कि अगर आपके पास RBr ho and you want to convert this into RNH2, so what you need to do? This is your AS part. Can you please tell me what is R? R is actually alkyl chain, and alkyl chain is actually telling the number of carbon. You can write any number of carbon over here. For suppose I am talking about 2 carbons, so I am just asking for this reaction. For suppose you have CH3 CH2 Br and you need to convert this into CH3 CH2 NH2. So what are the reagents that you need to use? What is the condition that should be used over here, and what is the type of reaction is this? Yes, bacho, do you know this? This is the part of AS. Yes, any one of you, bacho?
The NH3.
Yes, absolutely right. We need to use NH3. So the reagent over here is NH3. We need to use the reagent NH3 over here, but what is the condition over here? हमें ये NH3 किस तरह यूज करना है, किस चीज के साथ यूज करना है?
So heat under.
Yes, heat under reflux is absolutely right. But what about the solvent over here? Can you please tell me the solvent? Keep remember this, but if you talk about halogenoalkanes, so you cannot use the aqueous conditions. You cannot use the aqueous conditions because whenever you use aqueous conditions, so the halogenoalkane is going to be converted into alcohols. So remember this, if you are converting halogenoalkanes into nitrile, if you are converting halogenoalkanes into amines, so you need to keep remember the reagents in ethanol, right? So you need to use NH3 in ethanol, right? And the heat under reflux is the right thing you said. Also, the second condition is heat under reflux, right? So you can say that NH3 in ethanol you need to use, right? And also heat under reflux, right, bacho?
Yes, sir.
यस सर।
This is the previous one that you already talk about in AS, right? So keep remember the NH3 should be in ethanol, or you can say that NH3 concentrated as well. You need to keep remember the aqueous NH3 is not, you can say that a dilute one is not possible over here. Otherwise, OH is going to be substituted. And what is the what is the type of reaction is this? If I ask, this is reagent, fine. This is reagent, fine. This is condition, fine. Solvent, fine. And what is the type of reaction this is, bacho?
सर एडिशन रिएक्शन है।
No, not addition reaction.
Nucleophilic addition. Nucleophilic.
Substitution.
Yes,
Substitution है.
this is nucleophilic substitution because Br is going to replace by NH3 or NH2, sorry. Br is going to be substituted by NH2. So it is actually nucleophilic substitution reaction. This is actually nucleophilic substitution reaction. These all things are very much important for you. You need to keep remember all these things. These are definitely the previous part, but you need to keep remember, right?
Yes, sir.
Then we have second one as well. We have one more reaction over here, which is actually, if you talk about RCN, for suppose you have nitriles, for suppose you have nitriles. So whenever you have nitriles, you can even convert these nitriles into this form, right? You can convert nitriles into this form as well. You need to see this, bacho, that the C and N both are getting hydrogens over here. Both are getting hydrogen separately. This R is separately attached over here in both the chains. You just need to focus this, that the C in the nitrile is having hydrogen as well, and the nitrogen in nitrile is also having hydrogen in this reaction. So this is very important to understand that when you are going to do this, so the both elements are getting hydrogen, extra hydrogen over here. So what should be the type of this reaction, bacho? What should be the name of this reaction? Yes, any one of you, it's quite simple.
Sir, hi.
No. No, it's very simple. What is the thing which is going to add over there?
Hydrogen.
Hydrogen. So the addition of hydrogen is known as
hydrogenation.
no, one more thing. It is
Reduction.
yes, this is reduction. This is reduction. Whenever there is a gain of hydrogen, this is actually reduction. And in the reduction processes, what we need to use, bacho, definitely a reducing agent. So what should be the best reducing agent that we can use, bacho? What is the best reducing agent that we can use?
LiAlH4, sir.
Yes, absolutely right. Lithium aluminum hydride. And what is the solvent with this? Whenever we use this, what should be the solvent we should have? LiAlH4 in, it should be in dry ether, right? It should be in dry ether. This is actually dry ether that you need to use, right?
Yes, sir.
And you also need to know this, the condition for this reaction is again the same thing. You need to heat under reflux this, or you can even only say that heat this reaction, right? So the condition for this is heat under reflux. So actually, what is this reaction? You need to understand this. This is actually the reaction for suppose you have CH3, CN. You can see this, you have CH3, CN. You have one carbon over here. You have only one carbon over here. When you add lithium aluminum hydride in dry ether and heat under reflux, so you will see this, that you got amine, but the number of carbons are 2 over here. So you can say that we are actually attaching nitriles in the compounds to increase the number of carbon in the chain. You need to keep remember this. This is actually the main thing to remember. We actually add nitriles in the compounds, so the number of carbon in the chain can be increased, right? Let's see what I'm trying to say. I'm trying to say, for suppose you have CH3, CH2, Br. You have CH3, CH2, Br. See, you can form CH3, CH2, NH2 directly by this. You can form CH3, CH2, NH2 by this. You have 2 carbons over there, and you can produce 2 carbon amine from this. But for suppose you want कि sir नहीं, I want 3 carbon amine, so it should be CH2 NH2. I want this compound. This is the different compound, and you can see this now. The one carbon is going to be added over there. So if you want to add one more carbon to the chain, so you must need to place CN over there. So what I need to do, I just need to substitute CN over there first, and then I need to reduce this more. So in this way, I can add one more carbon into the chain, right? So for this, what I need to do, I just need to do NH3 in ethanol, right? That is the fine thing for reaction number 1. And for reaction number 2, what I need to do, I need to do NaCN in ethanol. This is also the AS part. You can add NaCN in ethanol, and then over here LiAlH4 in dry ether. In this way, you can form 3 carbon amine as well, right? It is ethane amine, and this is propane amine, right, bacho?
जी sir.
It is bromo ethane, it is ethane nitride, right, bacho? You need to keep remember this. Why we are going to attach nitriles in the chains? Why we need to do this? Because we want कि ये nitriles जो हैं number of carbon chains में बढ़ा दें. And you need to keep remember this reaction as well, that you can convert nitriles into carboxylic acid as well by hydrolysis. So you can even form propanoic acid by this reaction. This is also one of the previous knowledge you have. For this, what you need to do, bacho, you just need to do dilute acid or dilute sulfuric acid, dilute hydrochloric acid, या आप इसके अंदर aqueous NaOH या aqueous KOH भी use कर सकते हैं. What is this is hydrolysis. What is hydrolysis? We need to break down the compound in the presence of water, so that is why we need to use dilute solutions or aqueous solutions over here, right? And heat under reflux. Heat under reflux in all of these reactions, right, bacho?
Yes, sir.
जी.
So these are actually you can say that this is the main reaction scheme that you need to keep remember. This is very important, and this is, you can say that bromo compounds को कैसे नाइट्राइल्स में कन्वर्ट करना है. ब्रोमो कंपाउंड को डायरेक्टली भी अमाइन में कन्वर्ट कर सकते हो, ब्रोमो कंपाउंड को नाइट्राइल में कन्वर्ट कर भी अमाइन में कन्वर्ट कर सकते हो. बट यू नीड टू कीप रिमेंबर, ये हम क्यों करेंगे? जब हमें कार्बन्स बढ़ाने होंगे. अदरवाइज डायरेक्टली भी कन्वर्ट कर सकते हो, ठीक है ना? तो अगर आप डायरेक्ट की बात करो तो दिस इज द डायरेक्ट कनेक्शन, राइट? एंड दिस इज टू इंक्रीज द नंबर ऑफ कार्बन. ये वाला जो कनेक्शन है ये इनडायरेक्ट है, बट ये हम करते क्यों है कि हम इसमें इस तरह करने से हम नंबर ऑफ कार्बन बढ़ा सकते हैं चेन के अंदर. ठीक है बच्चों?
Yes, sir.
So you need to understand these question. For suppose अगर मैं आपको एग्जाम में कुछ इस तरह का सवाल आपको मिल जाए कि आपके पास यहाँ पर 4 कार्बन्स वाला कंपाउंड है, यहाँ पर आपके पास 4 कार्बन्स वाला कंपाउंड है और बीच में आपके पास गैप है, और यहाँ पर आपके पास 3 कार्बन वाला कंपाउंड है, लाइक दिस. ठीक है ना? So what we need to do बच्चों? We need to attach nitrile first, right?
जी जी sir.
Yes,
there,
sir.
there should be nitrile first, and then this nitrile can be reduced further to make amines, right? और अगर आपके पास जरूरत नहीं है, मतलब आपके पास अगर इस तरह का कोई कंपाउंड है CH3 CH2 CH2 NH2, यानी कि सेम कार्बन वाला कोई कंपाउंड अगर आपके पास है, तो इसका मतलब है यू डोंट नीड टू डू दिस. और फॉर सपोज अगर आपके पास है CH3 CH2 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 this is 1 2 3, this is COOH, 4 कार्बन वाला कार्बोक्सिलिक एसिड. तो you can understand this कि हम यहाँ पर भी जा सकते हैं. इसके लिए भी 2 स्टेप चाहिए होंगे. इसके लिए 2 स्टेप कौन से चाहिए होंगे? आपके पास 3 कार्बन है, 1 2 3 कार्बन वाला क्लोरीन है, आपके पास 1 2 3 4 कार्बन वाला कार्बोक्सिलिक एसिड है। तो इसमें जाने के लिए 2 स्टेप है, पहले नाइट्राइल फिर कार्बोक्सिलिक एसिड, ठीक है ना। सेम एज इट इज, आपके पास 3 कार्बन है और आपके पास यहाँ 4 कार्बन वाला अमाइन है। तो इसमें जाने के लिए भी वी शुड हैव 2 स्टेप्स, पहले नाइट्राइल्स और फिर अमाइंस, राइट बच्चों। और अमाइन में आप डायरेक्टली भी जा सकते हैं, बट कार्बोक्सिलिक एसिड में आप डायरेक्टली नहीं जा सकते, ठीक है।
यस सर।
एंड फॉर द टाइप ऑफ रिएक्शंस यू नीड टू सी दिस कि यहाँ पर आपके पास क्लोरीन साइनाइड से सब्स्टिट्यूट हो गया, सो दिस इज न्यूक्लियोफिलिक सब्स्टिट्यूशन। यहाँ क्लोरीन अमाइन से सब्स्टिट्यूट हो गया, तो दिस इज न्यूक्लियोफिलिक सब्स्टिट्यूशन। बट यहाँ पर आप देखेंगे कि यहाँ पर हाइड्रोजन ऐड हुआ है इन दोनों के अंदर, तो दिस इज एक्चुअली रिडक्शन। एंड यहाँ पर साइनाइड कार्बोक्सिलिक एसिड बना रहा है, तो दिस इज हाइड्रोलिसिस, right? And in all of these reaction you need to do what? You need to do heat under reflux, heat under reflux, heat under reflux. Heat under reflux is the main thing over here to do, because for the full reaction, and many of the compounds are ionic over there and some of them are covalent. So for the complete reaction we need to do heat under reflux over there, right? And the reagents are different over here. If you want to use you can use NH3 in ammonia in ethanol, you can use NaCN in ethanol. Over there you need to use dilute HCl or dilute H2SO4 or aqueous NaOH or aqueous KOH, any one of them, right? And over here you need to use LiAlH4 in dry ether. Is that clear, every one of you?
Yes sir.
Okay, now so we can move further to the next reaction then, and the next reaction is, for suppose I have amide, right? So for suppose if I have amide, जी बेटे
कॉपी करने का टाइम लेंगे?
चले आप कॉपी कर लें, कॉपी कर लें। चलो बच्चों आप लोग इसको लिख लो ताकि फिर हम, right? So you can see this is the functional group for amide, and for suppose we have H over here and we have carbon over here, carbon chain over here, so this is amide, right? This is amide. You can convert amides into amines as well. You can convert amides into amines as well. For this, what we need to do, we just need to break this bond, right? We need to break this bond, or we need to do something like कि ये जो आपके पास amide है ये किसी तरह से amine में convert हो जाए। तो कैसे convert हो सकता है? सबसे आसान तरीका ये है that if you have this amide CONH2, so you can simply convert this. We have oxygen over here. If we can convert this oxygen into hydrogen, so it would be good for us. We can easily convert this amide into amines. And this can only be done by the reduction process. So what we need to do, we need to reduce this. And for the reducing purpose, we always use the best reducing agent, which is LiAlH4 in dry ether. This is the best you can use. And for this, we know that we need to do heat under reflux. So in this way, you will see this, that over here, the carbon got hydrogen and the oxygen is going to be replaced by hydrogen, and the gain of hydrogen and the loss of oxygen both are the same reduction process. So you can say that this is also reduction. This is also reduction, and over here you need to use the reducing agent, and the condition is heat under reflux. So for suppose if you have CH3CO so you can convert this into CH3CH2NH2 by the presence of lithium aluminum hydride in dry ether. Right, every one of you? Is that clear?
यस सर। सर लेकिन O की जगह हटा के CH2 क्यों हुआ? CH नहीं हो सकता?
असल में कार्बन की वैलेंसी भी तो पूरी करनी है ना बेटा हमें। कार्बन के 4 बॉन्ड बनते हैं, तो एक नाइट्रोजन के साथ बना हुआ है, एक दूसरे कार्बन के साथ बना हुआ है, तो 2 बॉन्ड पूरे करने होंगे तो CH2 लगेगा। CH लगेगा तो 4 बॉन्ड पूरे नहीं होंगे उसके।
ओके सर।
ठीक है। Then we have one more type over here that we need to remember. This is the fourth one, right? So for suppose if we have nitrobenzene. This is for phenylamine. This is not only for amines. This is for phenylamine. If you have nitrobenzene, so we know that we can convert nitrobenzene into phenylamines. We can convert them into phenylamines easily. For this, what we need to use, we should use SN along with concentrated HCl. And also we need to do heating over there. So in this way, NO2 can be converted into NH2, and this is again the same thing. This is a reduction. This is again what the type of reaction is, reduction. Right, every one of you? Is that clear for all of you?
Yes, sir.
Any problem to any one of you? So you can ask.
No, sir.
Okay, so if you don't have any problem, so but I have a question for you, right? If you don't have any problem, so I have a question for you. So for suppose I have this compound. For suppose I have this compound, and then I want to convert this compound into this compound. I want to convert this compound, which is CH2Cl. I just want to convert this compound into CH2, NH2. So how can I convert this, Bacho? Can you do this?
Yes, sir.
Let's try this. Can you convert this compound into the required one? And also, if I have this compound, if I have this compound like this compound, and I just want to convert this compound into this, so how can I convert this? So here we have two practice sessions. This is exercise for you, right? Exercise question for you. Just try this, bacho. If you can do this, that's very good. Otherwise, I am here to answer you for this. Just try this with the reference of today.